we do have today is the last section for chapter 22. And there's no stat box. I started the stat box and then I didn't do it. So don't bother, we're not going to come back to it. Sorry about that. We are going to talk about independent events. Now we have talked about independent events today, before today. Today we will be getting a formula that we can use only for independent events. And we will work with that formula as well as some of the formulas from yesterday. And that's about it. Yes. Has it been 10 minutes? Once it's been 10 minutes. Okay. Independent events. So remember that the occurrence of one does not affect the occurrence of the other. So that's like, two things that they might overlap in a sense, but they don't affect one another. Rolling a die does not affect what color you spin on a spinner. So they don't affect each other. So this formula is only for independent events, and it's just that, remember, this means the conditional probability, so the probability of A given B, it's going to be the same as probability of A given not B, and it's just going to be equal to the probability of A because those events are independent. They're not related to each other. The bottom one is our most important formula for today, and it states that A and B are independent events, and this double arrow here means if and only if. The probability of the intersection of A and B is equal to the product of the probability of A and the probability of B. So if they're independent, then that is true. If this is true, then they are independent. So you'll have some problems that will say A and B are independent events. If they're independent, then you can use this formula. The first type of problem we will do is actually a question of, are they independent? So we can use this formula to check and see, because if it equals, yes, it's independent. If it doesn't equal, then no, it's not. So we have to use that and think a little bit critically on that. We're going to jump into 2 examples and call it a day. Are we ready? I would say we should have our formula packet out because we're going to be using some of those formulas from yesterday and some formulas in the past. So that's page 5, and it's section 5.5 and 5.6 of your IB formula packet. So we've got our first example, and personally, this section and last section are like not my jam. All of these formulas is kind of like when to use what. I know it's kind of a lot, but we'll work through a few examples today to get more familiar with it. The probability of T happening is 0.35. The probability of S happening is 0.6. And the probability of the union, so remember the union is both parts including the overlap, is 0.74. Are T and S independent events? To decide if they are independent events, we need to find the probability of the intersection of these 2 events. And we need to double check that this 8. Guys, I don't know. But like we don't know that they're equal. Like that's the thing. We don't know they're equal. We want to see if they are equal. So we have to check that out. Now I know the probability of t and the probability of s, so I can plug those in if I want, though it's not exactly necessary to do right now, but might as well. And again, I don't know if they are equal. Like I have to see if they are equal. If this ends up being 0.21, then I've got it. In order to find that intersection, I can use my formula from yesterday. So combined events, it says. So on your formula packet, it says combined events. This one's also on your formula packet under independent events. That's this part. So under combined events, we know the union of my two events, t and s, is equal to the probability of t plus the probability of s minus the probability of that intersection. So that was something we worked with yesterday, that we can find the probability of those combined events, so each event and that overlap. But to do that, we have to add the events separately, but we have to subtract that overlap piece. From here on out, it is kind of just like an algebra exercise that we've got to plug everything in and solve. So I know the probability of the union of t and s is 0.74. Probability of t is 0.35. S is 0.6. And what I will be doing is I'll be solving for this. So once I find this, I can plug it back in and see if it equals. So if I add up the 0.6 and the 0.35, I get 0.95. So now when I subtract the 0.95, I get 0.21, negative 0.21. So if I divide by negative 1, 0.21 equals the probability of the intersection of t and s. So it turns out that yes, they are equal. Yes, they are independent, but again, we have to make sure that they are equal. We can't just like do half the problem and call it good. So does that make sense? If it turns out they're not equal, they're not independent? Okay. The next question we're going to do has like 5 different parts to it, but it's a really good overview of almost every formula on the sheet. Actually, yeah, every formula on the sheet we are going to use here on the next problem, so it'll be a good refresher for us. Wait, except for this one. We already used that one. So this one is out of your textbook. It's out of the review section in the back of the book. It's got a lot of different parts on it. Two events are defined such that the probability of A equals 0.11 and the probability of B equals 0.7. Remember that capital P stands for probability. What does the N stand for? It's something that we saw early on, but then we didn't really talk about it because it's kind of common sense-ish. The number. So what this part means, the number of events that are event B is 14. So there are 14 events that are whatever B is. So just a little reminder that that's the number. So I'm going to use the formulas. Some of these you can do without that and just kind of like using what you already know. But I'm going to use the formulas for in case you forget something, you can always come back to this. So part AI says, calculate the probability of A prime. Now remember, that's the complement. So A prime is everything that is not A. So you can probably do this without this formula if you remember the relationship between complements, but if you forget, it's right in your packet. Complementary events, the probability of A plus the probability of A prime equals 1. So yes, you can do this without the formula, but just in case. So I have 0.11 plus the complement of A equals 1. So when I subtract 0.11 from 1, I've got the complement of A equals 0.89. So if you remember, complementary events add up to 1, you can just do 1 minus. You can make it a lot shorter, but just in case you don't, we've got that formula. Without using like the symbols and the formulas and the notation, how do you describe to someone how to calculate probability? The part over whole. So how many things in the event divided by the whole group of what could happen, right? We know that, but there is a formula for that in your packet, and it's the very first one. So again, don't really need the formula, but we'll practice with it. And I'm going to use B instead of A, but it says the probability of B equals the number of items in B, so that's that part that Steven said, over the number of items in the whole thing. Remember that U is our universal set, so that's the whole thing. So I kind of jumped into the formula without going back to the problem, but we can use this to find out, well, how many items are in the whole thing, because that's the universal set. So we know the probability is 0.7. We know there are 14 items in part B, but what we don't know are the total number of items. So now we can use that formula to figure that out. I'm just going to figure this. So we can swap those, so then the number of items in my set is equal to 14 divided by 0.7, which is 20. Are you ready for part B? I don't want to go too fast because, like I said, this is a really nice review of everything we've done and like connecting what we've done with all of the probability laws. So it says A and B are independent events. So this is the type of problem where, since they're independent, I can use that formula that we just learned, that the intersection is equal to the product of both A times B. So I know they're independent. I'm not checking. It says they are independent. So we have 0.11 times 0.7, which is 0.077. And again, this formula is listed right in your packet under independent events. Like it says independent events, there it is. So you don't have to memorize these formulas, they're right there for you. Now, we're going to use the formula, which could also be described as doing the most on this next one. It's definitely a way easier way to do it, but I want to connect it to our formulas, and maybe you can figure out what that easier way is. So A and B are independent events, so find the probability of A given B. So there is a formula in your packet for conditional probability, and that packet, or that formula is the probability of the intersection of A and B, equals the probability of A times that conditional probability. So this was one we had yesterday, though it was written in like two different ways yesterday. This is the second way that was on the board. So I can plug these things in. So 0.077 is that probability of that intersection, and the probability of A is 0.11. So then, yes.
How do you know which one to use for probability of A or probability of B?
Yeah, you know what I'm thinking? I did put the wrong one. Right? What I wrote I wrote this down wrong, right? This should be B, and then this is
That's B gives A.
in here. Yeah, so then we should switch this around. That one stays the same, but that one should be B. You know what? I missed that second hour. So this part should match this part. Whatever it's given that, these letters should match. So I did write that down wrong. And what was B7? So then when we divide, what do we get? 0.11? Which that makes sense because these events are independent. They don't matter. Like this is the same as the probability of A. So that's why we really didn't need to do all the work, but because A and B are independent, the conditional probability is the same as the probability for A. I just wanted to connect to those formulas, and it's a good thing I did because it kind of answered that question because I was getting confused on it. So thank you, Stephen, for bringing that up. Any question before we do the last part? I'm going to erase this red stuff then. So for this one, it says instead they're mutually exclusive. So mutually exclusive events also have nothing to do with each other, but they're just a little bit different. They don't overlap at all. So it says find the probability of that union. So the union, remember, is all of the parts, but there's no overlap. So we just have to add part A plus part B. Which, again, that formula is directly out of your packet. I'm not memorizing it. It's right in your packet. probability of that union is 0.11 plus 0.7, which is 0.81. So we've got all those formulas in there. Are there any questions? So then that's it. That's it for notes for the year. The year, that was it. We should celebrate. So here's how we're gonna celebrate. We're gonna just have to do 1 through 3. We're not doing that. That's done. We are really done.